Hello, welcome to ANS Solver. This is the seventh question of the paper. So the diagram has two curves, 4 cos half x and 1 over 4 minus x, okay, where my x is equals to a, okay. The tangents of the curves are perpendicular. So now I have two equations here, y equals to 4 cos half x, correct? And my second equation I have is y equals to 1 over 4 minus x. So I'll first differentiate both of them. Okay, I'm basically finding the gradient of both of them. So this will be basically 4 into the differentiation for cos is minus sine half x multiplied by, because the chain rule applies, it will be multiplied by the differentiation of half x, which is half. So I can simply cut 2 here to get minus 2 sine half x. Now when I differentiate this, I can write this as y equals to 4 minus x raised to minus 1. So my dy by dx will basically be the outer bracket first. So it's minus 1 into 4 minus x raised to minus 1 minus 1, okay, into the chain rule will apply. So the differentiation of 4 minus x, which is minus 1. So the value I get here is basically 1, sorry, so this will become positive because minus 1 into minus 1, and I'll get 4 minus x raised to minus 2, which can be written as dy by dx equals to 1 over 4 minus x raised to 2. Got it? So now I need to know that the differentiation for this is m1 and the differentiation for this is m2. Now they have told us that the tangents of the curves are perpendicular. Okay, if the tangents are perpendicular, I can say that basically the m1 into m2 is equal to 1 or minus 1 actually. If you remember your perpendicular theorem from IG or AS, okay? So now what I can say is it's basically minus 2 sine half. I can say this is half a because when the x is a, that time they intersect, or that time it's perpendicular. So this is what I get. Sorry, this is a square equals to minus 1. So I can cut the minus here, correct? So I can get simply 2 sine half a is equal to 4 minus a the whole square, correct? So now I'll just make a line here running out of space. Okay, so now I can write this basically as 4 minus a equals to the square root, because when square goes to the other side it becomes square root 2 sine half a. Now I can simply write this as 4 minus the root of 2 sine half a is equal to a, which I basically needed to prove here. Okay, it requires a little bit of common sense but easy to solve. Okay, yeah. Verify by calculation that a lies between 2 and 3. So my equation basically has a equals to 4 minus the root of 2 sine half a. So now the first step to solve a question like this, I write this as a minus 4 plus root 2 sine half a, which is equal to a, but we don't need to write it. Now I can say my a is basically equal to 2 and my a here is equal to 3. So now what I do is, in the place of a, I substitute 2. So I get 2 minus 4 plus root of 2 sine half into 2. Okay, so I can simply use my calci. Okay, here I can use the radian mode. Okay, simply. So 2 minus 4 plus root of 2 sine half into 2. So when I do this, the value I get is simply negative 0.7027. Got it? We care more about the sign, which is negative. Now in the place of 2, put 3. On the calci, just put 3 there. Okay? When you do that, you get the answer as 0.41244, which is positive. So A will lie between 2 and 3. Okay, there's a rule which you need to know. A will lie between 2 and 3 if there's a change in sign in the critical values. So I can just say change in sign, hence verified. This is what I can state. Now, use an iterative formula based on the equation in part 1 to determine A correct to 3 decimal places. Give the result of each iteration to 5 decimal places. So now I can write my iterative formula as A. I simply need to write this as A in n plus 1 equals to 4 minus the square root of 2 sine half an. So now the first step is always to take your n as 0. So when you take your n as 0, I get this as a1 equals to 4 minus the root of 2 sine half a0. Okay, now you need to know that a0 is basically can be the 2 or 3. Okay, because you know a lies between them. So let me take 2 for now. So I can write this as a1 equals to 4 minus the root of 2 sine half into 2. Okay, so I can get a1 basically as 4 minus, you can solve this on the calci. Okay, there's a numerical solutions, it's a full calci based question. So yeah, when I do this, I get my answer as 2.7027. Okay, so yeah, and 7.1 if you want, because they have asked us to write it to 5 decimal places. So you'll get 7.2 because that's 2.7. Okay, so now for A2, what I need to do is, where you have written 2, just click remove 2 and click on the answer button. Okay, just do that much. When you do that and click on equal to, the value you get is simply 2.60285. Now for A3, just click on equal to. So you get 2.61152. Now for A4, click on equal to get 2.61069. Now for A5, click again on equal to get 2.61077. Now click on equal to again to get A6 as 2.61076. Okay, now click on A7. Actually, this is not 6.6, you get 6.7 here if you round it off. Okay, now when you click on equal to, okay, you get this as 2.61077. Now if you see, the value you get here in the last 3 iterations are recurring. That means how many ever times you click on equal to, you won't get a different answer. So basically this is your iterative formula, iterative value, which you need to write to 3 decimal places. So your answer is simply 2.611, which is the final answer of the question.